for 2 hours.
You don't need to answer.
I could fill it out and then get all the credits.
So you weren't the only one, Jake.
No, you still need more and more.
Okay, guys, let's just do a couple review problems from yesterday. So let's classify a couple of polygons. So these should be in your notes.
I wasn't there, I was helping out. You were smiling. I really did. Logan? You were later? That didn't make sense.
It's a 6-1, so continue.
You missed Monday. It's Tuesday. I just have to come to school on Wednesday.
Okay, here we go, guys. We have a lot to do today. So, number one, how could I classify? I want to put any name that I could possibly put on these figures.
Quadrilateral, number 1 and number 2.
It's almost a quadrilateral.
Oh, not number 1, sorry. Just number 2.
Oh, I thought you just
Number 1 is what?
It's not a polygon.
It's not a polygon because it has a gap.
I thought that was just. Yeah, me too.
Okay. Number 2, what are all the names? I could name this way, this one tons of ways.
It's a quadrilateral.
It's a quadrilateral.
It is a polygon.
It is a polygon.
It's a square and also a rectangle.
It's a square.
Oh, it's a rectangle. It's not a square.
It's a rectangle, yeah. That's what kind of quadrilateral it is. What else? Is it regular?
Yeah.
It's irregular. Why, Keelan?
Because not all the sides.
Are all the sides the same?
Nope.
I mean, these two are and these two are, but they're not all the same. So it's close to being regular, but only a square would be regular for quadrilateral, right? So this is irregular. What else? Is it convex or concave?
Convex.
All the diagonals are inside, so it's convex. And there's one other name, but we'll leave that off. Okay? It's a parallelogram.
Oh,
Okay. Number 3, what is that?
that's a triangle.
Most generally, what is it first?
Polygon.
It's a polygon, right? And then it's a triangle. It's an equilateral and equiangular triangle, which means it's, we can call it regular. And then it's also
Convex.
convex. Okay, let's put one more in the mix. Okay, how about that one?
It's.
Is it a polygon?
It is a polygon. It is a polygon. It's not curved.
Nothing's supposed to be curved there. That's what you're saying, Chelsea. Okay, if it's got a curve, yeah, but we'll pretend my things are straight. Okay. It is a polygon. What kind?
Irregular.
It's irregular. True.
It's concave.
It's a pentagon, 5 sides. And did you guys hear Nick? He said it was. You guys in back. Why is it concave? What, Tristan? Because it looks like it's concave, right? Because this is a diagonal and it's outside. Okay? And I think that's about all we can say about that one. Okay, so that's kind of a quick review of what we did yesterday. Okay, we said to find the sum of the interior angles What's the formula? This one you need to know. I may continue to go back and put this on quizzes. N minus 2 times 180 degrees. So for the triangle, you're going to get 3 minus 2 times 180 is 180. And so forth, okay? Okay, so exterior, that's what we're going to look at now. So that was one theorem that we looked at yesterday. This theorem we didn't do. The sum of the exterior angles of a convex polygon is, let's try to discover this. Okay, so I'm going to draw just like a pentagon, and we're going to look at that. So let's say I have a pentagon that looks kind of like a house. You guys thinking that, despite my drawing, does this look like a regular or an irregular pentagon? The sides all look pretty close, but the angles, these are like 90s. Those are definitely not 90s. So this is irregular. It's kind of close to regular, but a regular pentagon would look more like that, wouldn't it? A little bit slanted. Okay. Yeah. So I'm going to take this and I'm going to draw one exterior angle at each vertex. So let's go right there, right there, right there, right there. I'm just like going clockwise. Okay, and I'm going to look at all those angles. That one, and that one, that one, that one, and that one. Okay, so I'm just drawing one exterior angle. So that's what I mean when I say the sum of the exterior angles. Okay. So can you guys look at that and tell me how many degrees that is, just looking at it?
Not quite. There's 2 natural angles. Wait. And those
Okay, it's tough, right? So this is the way that I'm going to do this. I am going to shrink it so you can see it better. So let's pretend I'm drawing the same thing, but I'm like going to shrink it down. Same exact figure. So let's shrink it down. And let's do the same thing. Do. Okay, can you guys see how much those add up to now? Still kind of tricky.
180 on the 2 90-degree angles.
Okay, so Nick's got, yep, there's the 180. Yeah.
And it has to add up to.
I'm not saying it has to add up to anything yet. We're discovering it. So I could do this with any convex polygon. This is what I like to do. I just shrink it down. So it's still kind of hard to see, I think. Let's shrink it down to where it's really little. So maybe really teeny. Oh, go on. Now I'll do these in red so you guys in the back can see.
Now it looks like 40, like 65 degrees, or?
Are we able to see what that is yet?
It's
What's
a
it looking
flower.
like?
Oh.
Let's shrink it down so far that it looks like a point, okay? So far that it looks like a point. So we've got one coming up like this. Oh, actually, no. Got one going out like this. I'm using the big guy as a guide. One like this, one like this, one like this, one like this. And the angles are going to be this angle and this angle and
Oh, 360 degrees.
that one and that one. So I draw next to it. Okay.
It's 360.
So it's a circle, right? How many degrees are in any circle?
360.
360. So does it matter what polygon I started out with?
No.
If you shrink it down, it's always going to look like a circle, right? So the sum of the angles that are outside any convex polygon is always Always 360. Doesn't even matter what kind of polygon it is. What do you need? Rulers? Okay, so let's look at some problems where we're using some of these theorems. So here's some examples.
Mr. Milligan, you have a phone call?
Okay, so remember, what's the highest number, or the highest number of sides on a polygon we need to know the name for? 12, and that was a dodecagon, right? So if it's beyond 12, we could just call it like a 16gon. So this one's saying find the measure of each angle, not the sum, but each angle inside a regular 16gon. Now there's a key word here. What's the key word that's going to allow me to do this? Regular. If it wasn't regular, do all the angles have to be the same size? No, so I really couldn't do it. But if it says this, n is how much? How many sides? 16. So if I want to do this, let's find the sum first, the total, which is what?
Oh, s equals to m minus 2 degrees.
So 16 minus 2 times 180, that's going to be 14 times 180. So now I use my calculator and I get a 16gon has 2,520 degrees inside of it. Now if I want not the total, they didn't ask me for the total. Be careful. These problems are going to be, you're going to have to read them very carefully. So they could ask you for the total, the sum, or they could ask you for each one. So what am I going to do with that if I want each one? It's regular, right? Divide it. So if it's regular, it's equiangular. All the angles are the same. So divide by 16 and we've got it. So each one of those angles is going to be 157.5 degrees. So can you guys picture this in your head? Is that really true? Like are all those angles obtuse angles for a 16gon?
Yeah.
Think of what a regular 16gon looks like. It's going to be like this, and then just a teeny bit, and then just a teeny bit, and a teeny bit, and a teeny bit, and it's going to keep going around. And each one of these angles is how much do we just calculate?
157 degrees.
157.5. So doesn't that kind of make sense that it's going to look like that? I think it should make sense. Okay. Okay. So there's one. Let's do another one. So say that we have a 13gon, and they say find the measure of each exterior angle. Again, the only reason I can do this so simply is because of what keyword in there? Regular. If they do not have the word regular in there, then all the angles could be different. You could still find the sum. I mean, yeah, you could still find the sum, but you couldn't find each one, okay? You couldn't do that division. It's not all the same. So since they said regular, that's key.
So is this regular? It has to be. Or what about convex?
If it's regular, it's going to be convex. Actually, someone in the other class, they thought that if it's regular, it has to be convex, doesn't it? Think about that. It's going to be the way it works. Okay, so that's a key. What's the other key word here that you want to underline?
Exterior.
Yeah, that's true. What else, though?
13.
Did it say sum?
Each.
Okay, so the sum for a 13 gon, you guys tell me how many degrees is the sum of the exterior angles for a 13 gon? 360, right? They're all 360. So the sum is 360, so if I want each one, I'm going to do what? Divide by 13. And that's just because it's regular, otherwise I couldn't even figure it out. So that's going to be about 27.69 degrees. Okay? And as I mentioned, you guys, if you don't put degrees on the final, I will mark the problem wrong. It will be completely wrong. I don't care if you have the right answer or not, it will be wrong. So if you leave units off, it's not going to work out for you. So I'm going to leave my units off, okay?
We're solving for a variable too. It's not.
I'm not going to be sticky about that, but if you have a quantity and it doesn't have units, it's not going to get you any points.
So it's either units or degrees.
Yes, the units on angles can be degrees. Angles come in other units. Angles can be measured in minutes, seconds, hours, radians, all kinds of things. Angles can be measured in those units, so you'll see that as you move on. Okay, let's do two more. Okay, so let's say we have that shape. What kind of shape is this?
It's a pentagon.
It's a pentagon, right? So the way that you name shapes, you will call this pentagon A, B, C, D, E. It doesn't matter where you start. Like you could start with D and say pentagon D, E, A, B, C, but you can't go like pentagon D, B, A, C, E. You have to like pick an order and like rotate around either clockwise or counterclockwise, okay? Because that tells you like what order the vertices go in. So I'm going to find the measure of each angle. This guy's not regular.
What's C? Oh. Oh.
Okay, so Sean, you tell me how many degrees are in that pentagon total? Okay, so how am I going to find the sum inside the pentagon? Yeah, how many do these all five add up to? You don't have to tell me the answer, but how would I find it?
I didn't find the sum of all.
What's the formula?
Oh.
Times 180. Okay, so now what do I do with that? Plug in what? 5 minus 2. Chance. You want to tell us what that turns out to? So you can use your calculator if you had to, right? So this is 540 degrees. It's also nice to remember some of those shapes, like a quadrilateral is 360, pentagon is 540. It's nice to know a couple of them at least, but you don't have to, you can just do that, okay? So I said not find the sum, I said find each one. So now what am I going to do? Now, Sean, you were telling me kind of what to do. Hold on. So how am I going to use that to find each one of these? We were on to it before. What should I do, Jake?
Okay, add all those up.
Add them all up and set them equal to.
And then divide them.
How much are they supposed to be equal to total, though?
They gotta be equal to 5.
Okay, so this is just like what we did with triangles. And set it equal to 540 because that's the total. So then combine all those like terms. Let's see, I got 135C equals 540 and then divide, like Jake said. So then divide on both sides. I get C equals 4.
And just plug C in there.
And then just plug C into everything and you'll get each one. So you could say measure A, we'll just do a couple. So A is going to be 35 times 4, which is 40. B is going to be 18 times 4, which is
72.
72. C is going to be 32 times 4, 64 times 2,
Oh, wow.
128. Okay, we'll find them all that way. Alright, let's do one more, just one. Okay. So remember, this naming convention. If I say polygon JKLM, what kind of polygon do you think that is?
It's a it's a quadrilateral.
It'd be like a rectangle, but
Quadrilateral.
you know it has to be a quadrilateral because it could be like slanted and stuff, right? Okay, so I'm going to draw it. I'm going to extend some exterior angles. J, K, L, M. So just from that, like if I looked at this picture and it didn't have the vertices labeled, I wouldn't know which one is which, but I would at least know that they have to go in some kind of order around the outside, okay? And they also told me that,
R is a variable, right?
yeah, R is the variable, so that's 4R degrees. This is 8R, 5R, and 7R. Okay, so this is pretty similar to that last one. What's the sum of these exterior angles, Logan?
The sum of the exterior angles would be, you would have 5, 4s, 9s.
Yeah, you're gonna end up doing that. But how many degrees is it total? We should know.
Oh, it's gonna come out to
Shrink it.
360
yeah,
degrees.
just 360.
360. Okay. So then, what were you gonna do with those?
And you add up all the angles. 12 is 24.
Okay, so 12 and 12 is 24. Very good. And then you do what? Divide by 24, and you get 15. So that one was pretty easy, right? But the key here is you need to know that outside any polygon, they add up to 360, no matter what kind it is. Inside any polygon, they add up to different things depending on what it is. If it's a pentagon, they add up to 540. If it's a quadrilateral, they add up to 360. But you're going to have to use this formula to get that if you don't memorize each one, which I don't recommend. It's nice knowing at least triangle, quadrilateral, and pentagon, but I mean beyond that, I mean you're not going to memorize all those. There's no point. You just need this formula, and then you can get any one that you need. Okay? So really, we're just extending what we did with triangles to other polygons now. So we've done this kind of thing before. Okay? All right. You guys have until tomorrow to get that done, so you have the rest of the hour.